They hung up on me. No, like I picked it up and it was gone already. Yeah. Okay. So this would be the Lewis model. Okay. Now, like I said, I can move these electrons anywhere I want. We'll eventually get into why I'm kind of moving them away from each other. Okay. But eventually, how many bonds will this one have that you guys said? 1, 2, 3. This is a triple bond. Okay. So if you ever see 6 electrons inside of there, this would be 3 bonds or a triple bond for that example.
What happened to superstack all of a sudden?
Well, they're all super stacked. Right there. Super stacked.
Okay.
You have
to do the Lewis diagram?
Hmm?
You have to do the Lewis diagram?
I will ask for both, yeah.
And so the structural diagram of nitrogen would be 3 lines between it then?
Yes.
Okay.
Right there.
Oh, I didn't see you draw that.
Right there. Okay? So, if you ever see 6 in between, okay, 6 little electrons in there, that means it's a triple bond. All right? Okay. Carbon, on the other hand, okay, carbon is actually special. It tends to actually kind of do its own thing, and that's why it becomes super important in the world of organic chemistry. We'll talk about it a little bit afterwards, but for now, we're going to keep moving on with the molecular structures, okay? All right, so the next thing we're going to use molecular compounds to make molecular structures. Okay, so this is where things are going to start getting a little bit trickier, and this is also why it explains that some things actually will just why sometimes we write CH3COOH, okay? Why is it that we write C2H5OH, okay? So, some of this is trial and error, and some of this is actually just trying to put things together just to figure out where things can actually orientate themselves, okay? So, we're going to try to draw the Lewis model. I'm ESL too, so don't forget. English as a second language. Okay, so draw the Lewis model for methane. What? I know. That's why we get along, Matthew. Okay, so draw the Lewis model for methane. Okay, so first off, we want to think about what methane molecule looks like. Okay, so we know it's CH4. Okay, so what you're going to do, this is the baby steps. Eventually you guys are going to get so good at this that it's not even going to take very long for you guys to figure this out. Okay, so carbon. Carbon has how many valence electrons? 4. Okay, hydrogen. We have 4 of them, but every single one of them has an electron that it's looking for. Does everybody agree with that? Okay, so this is your job. This is the thing that you guys are going to start kind of putting together. Where or how can these orientate themselves around perhaps the carbon,
All around the carbon
to make it happy with the octet rule for every single atom that's involved? Okay, this is a molecular compound. Okay, so does everybody agree that this is what could happen? You betcha.
If we draw it wrong.
Okay? Well, I'll count up the electrons, yes, but otherwise, like, that's how you'll orientate itself, okay? So, this is how your methane would look like, okay? So, does carbon have 8 electrons around it? Yeah. Does hydrogen have 2 electrons around it? Shh. Does hydrogen have 2 electrons? Because it only wants 2 electrons. Hydrogen's that funny one, okay? So, if we were to draw the structural diagram for this, this would just be something like this. Agreed?
Do we have to start like that, or can we do like H?
Well, I will tell you. Well, no, because you have to have them all around there with that single bond showing that they're kind of splitting up in opposite directions. Okay? Sound good?